All right, everyone, welcome back. So in this part of the lesson, we're gonna take a look, and some of this is gonna be pretty familiar to you guys, especially with the review that we did last week. So we're going to do some basic arithmetic with functions and looking at composition, which is something that we did last year and we reviewed last week. So adding, subtracting, multiplying, dividing, and then composition of functions. And then we will talk a little bit about implicit functions and how you can take an implicit function and what an implicit function is, because that might not be something you're familiar with, or at least that word, you are actually familiar with them, and make them explicit. So with that being said, let's take a look over here. So some difference, product, and quotient, and you guys did these, right? So you just got to pay attention to the notation and how it's kind of written out and what's happening here. So this just indicates that you're adding two functions, f of x and g of x, subtracting two functions, multiplying two functions, right? Remember, that's different than composition. When composition, this will come up in a few minutes, but composition was, you could see f of g of x, right? You could see f of g of x, right? So just pay attention to the difference between those two. And then dividing, and be careful here that g of x, the function that you're dividing by, can't be 0, right? Logically, can't divide by 0. So the domain of the new function is the intersection, so it's like the combination of the domains of both f and g. So in this first example, f of x equals ln of x, and g of x equals the square root of 2 minus x. Write down, remember what that indicates, f minus g of x, and state the domain. So the subtraction piece of it, f minus g of x, is going to equal to ln of x minus the square root of 2 minus x. There's really nothing else we can do with that. That's why it's just a write down question. State the domain. So let's look at them. If it's the intersection, let's find the domain of f of x, and let's find the domain of g of x. So the domain of f of x, well, think about what is true about the argument of a log function, right? It's got to be greater than 0. So for that one, x has to be greater than 0. For g of x, domain of g of x, what can you know? The square root, what's under that radical? 2 minus x has to be greater than or can equal to 0, right? So if we solve that, x has to be less than or equal to 2. So I need the intersection of these two things. So that tells us that x has to be greater than 0, but less than or equal to 2. And that's it. 0 is less than x is less than or equal to 2. Or I could write it as 0 to 2, including 2. Right, so that's going to be our domain. Amazing. Let's look at these. So we're given P of t and we're given Q of t. So here we want to divide the two, right? So, and we're going to say the domain also. So we're going to write down the expression 5t minus t squared divided by the negative square root of t. Cool. And when we find the domain, let's find them separately, right? So let's focus on the domain of P of t. Are there any restrictions? No, that's just all real numbers, isn't it? And then if we look at Q, well, this has to be greater than or equal to 0, but because it's in the denominator, it can't equal to 0, right? So I know that t has to just be greater than 0 for that one, right? Therefore, your domain is the intersection of the two, so t has to be greater than 0. It can't be equal to 0 in this case because of the division. Here, you're doing q times q. So negative square root of t times the negative square root of t. Ooh, what's that? That's going to be just t, isn't it? So what do you think the domain is? Be careful. Right? We simplified this. I want you to go back and think about where these came from. Like, we built this function. This is actually not linear. Right? I multiply, like, there's something that stopped me back here. If it works here, it's got to work here. So you have to think about this is simplified, which we should do. We should be simplifying. However, you have to think about where it came from. This is the function. So look at it before you simplify and know that, oh, t's actually got to be greater than or equal to 0. There is a restriction. Think about where it came from, which we talked about a little bit last week, and we did talk about this last year as well. So I want to actually put these, and I already have them graphed, so I want to pull up the graph. This writing's going to go away, so sorry. Oh no, too fast. So if I go ahead over here to the graph, so here's the first one you can see, right? So we said t was greater than 0, and you can see what happened there, so I plugged it in. And then this one's pretty cool because when you simplify this, it's just a line. When you graph this, you just get this piece of the line, right? So it's just where it's greater than 0. It's not where it's less than 0, which is neat to look at. Okay, so now let's transition a little bit and talk about focusing on composition and review this. So domain, and that piece that we just talked about is going to be very important, is we want to look at the domain before we simplify the expression, right? And so this is what we just talked about with paying attention to the formatting of it. So here we're doing f of g of x. So f is composed of g. We're going to be substituting g of x in. So 4 times x to the 3/2, think about what that means, squared. Right? So I should simplify, and when I simplify, I'm just going to get 4x cubed, which would result in a domain of all real numbers. But are there restrictions here? Right? Aren't there? When you raise something to the 3/2 power, well, 1/2, that 2 in the denominator of that fractional exponent, means you're taking the square root, right? So x actually has to be greater than or equal to 0. And again, if you don't believe me on this, go ahead and graph this, right? You should simplify, but this, you have to remember, is composed of other functions, and you have to think about it's like roots. It's parents, if you will. G of f of x. So this I'm going the other way around. So I'm going to be substituting in f of x. So g is composed of f. So I couldn't find the function there for a second. 4x squared to the 3/2 power. Ooh. So again, I should be simplifying. I still get 4x. No, my math is wrong. I need to distribute. Come on, Miss Gowan. So I get 4. No, I don't. Why do I keep doing that? 4 to the 3/2, it's the square root of 4, which is 2. 2 to the 3rd is 8. I got it. I got it together. 8x cubed. How do we feel about that? Well, what happens here? Let's graph this. So what were my two functions? 4x, it's going to go away. Oh no, it's okay. I have it written somewhere else. 4x squared. Oh no, boy. I need this to go away. What was it to the 3/2 power? Are there any restrictions to x? You need it on projector mode. There we go. No, right? So the domain would be all real numbers. it deleted. Okay. So, oh man, it deleted. So where was I? With this one, right? 4x, what did we have? Squared to the 3/2. And we just figured out that the domain, so we had 8x cubed, and then we just figured out that the domain was all real numbers. So I want you to go back here and think really quickly. Not really quickly, but think. And this is kind of just a important piece of information here. Think about when you're, because really what's happening here is we're taking the square root, right? We're doing the square root of 4 and the square root of x squared, and then we're cubing it, right? If I do it in pieces. So I want you to think about what the square root of x squared actually is. So think about the numbers you can plug in, right? Versus the numbers that you can actually take the square root of. So this is actually the absolute value of x, right? When you take the square root of x squared, it's the absolute value of x, right? The whole idea, think about it as like it's plus or minus x, right? That's why it's the absolute value of x. So this is actually, I should be writing the absolute value of x cubed. So that's kind of a minute detail. It's a little bit confusing, but hopefully that kind of makes sense. Right, so I ended up when I just went to go solve it, but if you're trying to think through it logically, I need these absolute value symbols because that's going to impact what the outcome is, right? If you take a negative number and cube it, it's not the same thing as taking a positive number and cubing it. So be careful here. This should be the absolute value of x for this reason. So the domain is all real numbers. Amazing. Okay, a few more. Find non-trivial functions f and g such that h of x equals f of g of x. Right, so h of x is f of g of x. So g is the one that you're plugging in, f composed of g. So we would want, in this case, think g of x is going to be x plus 1, right? And then h of x is going to have to be x squared minus 3x plus 4. What about this one? G of x, I'll start from the inside. I'll say is x cubed, and I guess there could be other answers. And f of x is going to be the square root of x. Right, so that's like undoing the composition. Okay. And this is going to be a little weird or a little different to us. So implicit functions versus explicit functions. So an implicit function, or I guess I'll start with explicit. An explicit function is when the dependent variable is clearly defined or clearly stated in terms of the, I just said that the wrong way. The independent variable is clearly stated in terms of the dependent variable, right? So it's like you have like y equals x, right? The variables are on opposite sides. But there are some pretty important, and you've seen them, relations that exist that are not functions, like a circle, right? And that is an implicit function, but we could actually define it explicitly. So one example is this right here. So there's going to be which ordered pairs satisfy it. So if I were to go and plug in, right? So if I plugged in 2 and -5, does it work? Is it true? This is true. I'm not going to show the whole thing. You guys can do that. If you went and did this one, it's not true. If you went and did this one, it's true. Actually, when you go and graph this, and this is a pretty cool one to graph, it looks like this, right? So this is not a function. It's interesting, it's cool, but it is an implicit function, right? Y is not defined in terms of x. I feel like I said something backwards at one point, but it's okay. We're just going to go with that. Implicit functions are hard to graph. We can graph some relations such as, a circle with a radius of 2 and a center of 0, 0, as two functions by solving for y. So if I went ahead and solved this for y, let's see, y squared equals 4 minus x squared. And I take the square root, I'm going to get y equals the square root of 4 minus x squared, and y equals negative square root of 4 minus x squared. right? So I get two functions here. Oh, there they are. Since the two functions are satisfied under the same conditions, we say that x squared plus y squared defines the other two functions implicitly. So this is implicit. These are explicit. So if I went ahead and actually graphed this, I'm going to go back to my Desmos. How many things do I have graphed now? I'm just not going to get rid of any. So let's go ahead and look at those two. The square root of 4 minus x squared. Oh, do I need to write y equals? Where is it? Oh, it's up there. There you go. Look, that's the top half of it. It's the top half of the circle. And then this is going to be really crazy. 4 minus x squared. The bottom half of the circle, right? So that's the circle with a radius of 1. How neat is that? So that brings us to the end of this lesson. Right, so this is a little bit weird and it's a little bit hard to think through. It's a bit challenging, but hopefully some of this makes sense and we got some good review from this. And go ahead and if you are ready to try some practice, go for it. If you need to go back and rewatch anything, amazing. And thank you, everyone.